In this video, we'll discuss another common leaving group, which is often abbreviated as OTS. TS stands for tosylate, and OTS is an oxygen that then is connected to the tosylate group, which is this guy. So it's just a large resonance stabilized leaving group, and so it's a good leaving group. We can think of it kind of like an iodine, or maybe even a better iodine, but you should treat it the exact same way in that it just leaves as a leaving group as one of the halogens would. So the tosylate leaving group is often how we convert an alcohol into a better leaving group if we don't want to use acidic conditions. So one thing we could do is add H+, but perhaps we have something else on our molecule that's acid sensitive. And so this guy in and of itself is a poor leaving group. If it left, it would be OH-, which is a strong base. So what we can do is we can convert that into a better leaving group. So what we do is we put a tosyl chloride in solution, so that chloride itself is going to act as a leaving group. And then this is usually done with pyridine, which is a weak base. So under weakly basic conditions, what happens in this reaction is it's actually an SN2 reaction in itself. You have a lone pair from the oxygen come in and attack the tosylate and kick off the chlorine leaving group. So now I have my tosylate connected, and then I have my oxygen that now has a positive charge because it has an extra bond on it, and then we have a chlorine that left as our leaving group, and at this point the pyridine will come in and deprotonate for us. So this is a good base. It grabs that proton, those electrons go on to the oxygen. Since it's an acid-base reaction, we can use backwards and forward arrows, and now we have this good leaving group here, and then you just get as a byproduct a salt. So the positively charged pyridinium is going to be attracted to the chloride ion that left from my original tosyl chloride that I used to substitute. So now that I have a good leaving group on there, I could take this OTS group and I could put it in there with iodide, for example, which is a good nucleophile. The iodide would come in, attack that carbon, kick off the leaving group, and I can have propyl iodide, whereas had I tried to do that here, I would just get no reaction because this is a poor leaving group. So sometimes when you have a starting material and you want to run a reaction, you need to modify it in order to get the reaction to go. This is one of those cases. If we have just an alcohol, it's going to be a poor leaving group, so either we need to convert that to a tosylate leaving group, or if we wanted to run the reaction under acidic conditions, we could just add H+, protonate it, and then have water as a leaving group.